All right, here we go. Page 13 of Unit 10, or the continuation of Unit 9. This is the last day of notes. All right, so what we're going to be doing today is just comparing like a function I give you and trying to determine what derivative graph it would match up with. So we're looking at graphs. So we're going to compare and relate original function and derivative graphs. Sorry. All right, so when the derivative graph is positive, so above the x-axis, we're talking about the y values. Above the x-axis, sorry, the y value, yes. The function is increasing. So this is actually kind of working backwards a little bit, but we can work the other way too. So when the derivative is above the x-axis, we know that the original function is increasing. When the derivative is negative or below the x-axis, we know the original function is decreasing. And when I have the derivative of the function is a 0, the original function had a max or min. So we can take it from the derivative back to the original, or we can take it from the original to the derivative. So either way we do it. So I'm going to use some highlighters a little bit and show you some stuff. So we talked about this a long time ago. I can't believe the year's almost over. So when we talked about this original function here, we talked about this graph going up to the right, that this was an increasing part. It would get up to here and then would have a decreasing part. And it would get down to here and then it would increase again. So this part here, when it's increasing, that means on the derivative it's above the x-axis. So then I hit this point here. So these maximum or minimum points, let's see, this is at 1, -1, -2, -3, -4. This max or min point is going to be a 0 over here. So if I set -4 here, if you look, -1, -2, -3, -4, that's where the maximum was on the original function. Now the original function then takes a turn and goes down or decreases to there. And so when it's decreasing, the derivative is underneath the x-axis until we get to here, which is at sorry, when I get to a min here. So that's at 1, 2 on the x-axis, so 1, 2 on the x. And then again we have another increasing function again. So this means, again, we're above the x-axis here. Okay, so we have increasing, a max, a decreasing, a min, and then increasing. So that means we have above the x-axis, a 0, below the x-axis, a 0, and then above again. So when we talk about it in the function, this would be considered your backtracking part. So a negative output would be between these two zeros, so at -4 and +2. These are going to be negative values for the y. So this is green part is referred to the backtracking. Alright, so just to kind of put it down on paper, the function is increasing. The first increase part is from -infinity to the x value of -4. The function decreases from -4 to +2, the x values. Sorry. And then from the 2 positive 2 on the x, and keeps going for the x. So those are my highlighted parts. My max, no, you don't always, you might have more than one because they're local ones, they happen at different points. You have a maximum there and you have a minimum here. So when we take those information and compare it straight across, the derivative is positive y's, so y values, from negative infinity to negative 4. Hey, those match up. Oh, left, right. The function is decreasing from negative 4 to 2, so the derivative is negative for the y value underneath the x-axis from negative 4 to 2. Hey, they match again. Alright, and then lastly, the function increases again from 2 to infinity, so ironically, so does the derivative function. It's above the x-axis, so the y values are positive. It has 2x intercepts at negative 4, 0, and positive 2, 0, and those match with the x values there, match with those there. Okay, we already talked about this. If the original function were a positive function for a particle, when would it be backtracking? So from negative 4 to 2. When would the velocity, so first derivative, and it's looking at when, so that's the x value of the lowest point. So lowest point is here, so the x value is the when. What would be the lowest velocity? And it's negative 9 and whatever the units per time. And lastly, when would the acceleration, the second derivative, be 0? Those two are the same. So same as velocity, when the velocity is the lowest, that's when if I were to do another derivative here, the acceleration function would be there, and it would have a slope of 0. So at negative 1, I should put time, or yeah, unit of time. Alright, so that's all we have for today. We're going to finish doing some graphs and matching up on Monday, and then we're going to start reviewing for your test on Wednesday. Talk to you soon. Thanks. Bye.